As mentioned, I'm Max Lobovsky, co-founder and CEO of Formlabs. Just a little bit of background. I was a student here with the two other co-founders of Formlabs, Natan Linder and David Craner. I was in the Center for Bits and Atoms with Professor Neil Gershenfeld, and we were always looking at new types of fabrication and how we can combine computation and fabrication to kind of achieve new possibilities. And so we started the company to basically get better access to high-quality professional 3D printing to more people. And so that's kind of what we've built. So we make a printer, we make the software that drives it, we make the materials that go in it, and basically give you a complete end-to-end system. So to date, we've shipped something like 35,000 printers and 15 million, and those printers have printed over 15 million parts for our customers. And just a little more information about the company before we kind of dive into a broader view of future manufacturing, where we are today. About 350 people, most of them here in Boston, also manufacture around the world and shipping products around the world. So, manufacturing. First of all, normally when I speak to people about 3D printing, kind of assume that they understand why you might care, but I'll dive into that a little bit more. So why 3D printing, and more broadly digital manufacturing techniques in general, which is kind of defined as applying computing to manufacturing. There's a few big reasons. The ones that I think are the most interesting, number one, the biggest one, is customization. To be able to make products that fit individuals better, that are more customized for different styles, tastes, regions, needs, many different reasons that you'd want a product to fit. And this is something really important because most of manufacturing has trended towards making more of one thing rather than making more types of a thing. So being able to kind of fight that trend is a powerful thing. Faster time to market, if you can avoid tooling or other kind of startup parts of the process, you can bring products to market faster. Redundancy, if you're using many kind of identical units to produce something rather than one very high output piece of tooling. And in general, more agility in manufacturing, where you can have less inventory within the supply chain, make things as needed, change products as needed. So this is why you should care, basically. So now talking a little bit more specifically about 3D printing, where is 3D printing in terms of producing higher volume stuff? This is one very simplistic way to look at all the things that humans make. Humans make a whole range of different things across different size scales and across different volumes. So we make some very high value specialty stuff in quantity one, like satellites or expensive cars, to mass-produced items, up to hundreds of millions or billions of items, of identical items. And I think 3D printing has already proven itself as being very useful and important for making 1 or 10 or maybe 100 of something. But is it applicable to all this other stuff that we make in much higher volume? So there's at least one good example that's gotten a lot of press in the last couple of years. That's this GE fuel engine nozzle for their next generation jet engines. Really exciting, uses new metal 3D printing techniques and achieves higher performance and a lot of these great benefits. But it's actually not terribly high volume in the grand scheme of things. So are there any examples of 3D printing being used in high volume? I think this is an important question because if we want to see more of it, we should try to find at least one place where it's happening. And there's one really good example. It's this thing. This is an Invisalign clear dental aligner. And these are made in quantity of tens of millions per year. Basically, it's a type of braces that will fix your teeth. And they need to be made to fit your teeth exactly. They're not printed directly, but every single one has a different printed pattern from which it's made. And so this is kind of an amazing example. This company is now crossing $1 billion in revenue. with all of their output based on these parts that are made with 3D printing. And it kind of really shows you a great example of where you want that customization down to every single part being different to gain some benefits for a product. But unfortunately, it's sort of like a standout example where it's far ahead of the next kind of biggest thing in 3D printing. So will we see more of this, and what does it take to move 3D printing further into production? We think there's kind of two big directions that will enable that, two things that 3D printing technology needs to advance in that will allow it to be applicable for more high volume production. Number one is materials, because ultimately if your part has different requirements about its mechanical properties or biocompatibility or all kinds of other things, and if you don't have those, if you can't meet those requirements with the part, you can't make it with 3D printing. So there's a lot of new applications that are being opened up through better materials right now. Two kind of interesting ones. One big area is in shoes. Most shoe companies are now trying to apply 3D printing to their production. This is a specific example of a partnership that we're working on with New Balance, where we're printing the plates of these athletic cleats. And again, the benefit here can be in customization and also in time to market and flexibility in their supply chain. They make, even though these are mass-produced items, they make so many different varieties. So 3D printing allows them to get more variation, fit your feet better performance, all those things. But the key challenge here is you need some really high-performance materials to survive on the bottom of a cleat as you're running around on it all day long. And so that's kind of the key innovation that can open up that application. Another really good example is back in the dental area. These are 3D printed dentures. And a denture is really demanding in terms of materials because it's got to be very biocompatible and mechanically capable. So this is another area where we're pushing 3D printing to new applications with new materials. The other big area is reducing the cost per part of something that's 3D printed, because today, typically, 3D printing is more expensive than other production methods. A really good example of that is on the left, we have 3D printed hearing aid. This is actually fairly common today, fits your ear better than a conventional hearing aid. But we're all walking around with earbuds that don't fit and are not comfortable. Why don't we have 3D printed earbuds that fit our ears? We believe it's largely because they're just too expensive to become a mass consumer product now. The hearing aids cost thousands of dollars. So it's a great example, and there's a number of startups working on trying to make that happen at scale. And if we just want to talk about how bringing down cost enables new technologies, the best example everyone likes to talk about is in computing, where the dropping cost of the transistor opened up a huge number of applications for computing. And Media Lab, in large part, has kind of been built on building out those applications, but most of them stemmed from this dropping cost per part, that if computing wasn't getting cheaper and more available, we wouldn't have been able to do as much with it. So we saw computing go from mainframes in big companies all the way to supercomputers in our pockets. And so we see kind of a similar analogy with 3D printing happening over time, where the price is coming down, and the applications that are done with 3D printing today are the ones that are higher value, a prototype or a one-off tool or something like that. But as we can bring that cost per part down over time, more stuff will make sense to be 3D printed, and we can get all those benefits. And so as a company, this is kind of one of our main focuses, to bring down the cost per part of things made with 3D printing. And by that, take 3D printing from prototypes to all sorts of high-volume produced parts. And there's a lot of elements to this, bringing down the cost of the equipment. That's something we already put a lot of focus on. We make fairly low-cost machines, but there's also the cost of materials and the labor that's involved. So one of the big things we're doing in this area is something we call FormCell, which is an automation system that runs multiple printers. and takes out a lot of the labor, which actually drives a lot of the cost in 3D printing. But this is just a piece of the puzzle. And in general, I think it's going to require work across the whole industry, hardware, materials, software, to bring down the cost per part and bring 3D printing into more applications. And I think that's going to be a really important part in the future of digital manufacturing. Thank you.